Hello, my name is Spruce Struneman. I'm an assistant professor in the Environmental Sciences Department at the University of Montana Western. I specialize in studying past and current climate, and I utilize water isotopes from ice cores extracted from polar regions like Antarctica and Greenland to reconstruct past temperatures and climate. One of the unique things about ice cores is when you extract ice cores, you can look at both the water isotopes, which tell you information about past temperatures, as well as the isotopes of gases in the air bubbles, like carbon dioxide, oxygen, methane. And what we can see in those trapped gases in carbon dioxide is we can actually look at the isotopes of the carbon and tell where that carbon has come from. So with continued fossil fuel use over the last 200 or 300 years, we have seen a shift in the distribution of those carbon isotopes. So fossil fuel sources have more depleted carbon isotope signatures, and we can fingerprint that today in the modern atmosphere and compare it to the isotope signatures from ice cores before human intervention. So we can see now that the atmosphere has roughly a quarter of its CO2 is from fossil fuel sources. Now this is important because we know that the changing carbon concentration in the atmosphere, carbon dioxide, must be coming from human sources. And in the long term, the increased CO2 in the atmosphere has an effect on warming the climate. It's a greenhouse gas trapping the radiation that's trying to escape out to space, and it slowly warms Earth. So as we continue to emit more fossil fuels, we can project that we will continue to warm. That rate of warming is understood in the physical system, and that has major implications for glaciers around the world, both in polar regions and in high alpine regions like Glacier National Park. So Glacier National Park had over 150 individual glaciers over a century ago, and now we've lost more than half of those glaciers. And this has impacts locally on stream flows, the amount of dissolved oxygen in the streams, stream temperatures, which is all important for the fisheries of Montana, as well as the recreational and commercial side of fly fishing and river trips. So in the future, as we move forward, we can expect to lose most of the glaciers in Glacier National Park unless we were to have some increase in snowfall each winter, but we're not seeing these increases in snowpack. Instead, we're seeing long-term decreases in the amount of snowpack at the end of each spring season. And that's really affecting stream flows, irrigation, and in general drought-like conditions in Montana.